Hi, welcome back after the break. Today I resume with long form videos on my channel. Okay, on today's tutorial, we want to look at two nice questions. The first one is on logarithm, the second one is on indices. The first question, show that log to the base 3 of x is equal to log to the base 27 of x cubed. Then the next part, find the real values of x for which 3 to the power x minus 7 is equal to 18 multiplied to 3 to the power x. Okay, let's get started. The first part, we want to show that log to the base 3 of x is equal to log to the base 27 of x cubed. We want to show that this left hand side is equal to the right hand side. Okay, so if we take the right hand side, if we work with the right hand side to get the left hand side, so we want to show that log to the base 27 of x cubed will be equal to log to the base 3 of x. Now look at it carefully. If we let this log to the base 27 of x cubed to be some value, say n, then we know from the relationship between logarithms and indices that this base raised to that power will give us the argument x cubed. And so we have 27 raised to the power n will give us x cubed. Now looking at this, remember I want to solve for n. We know that 27 is 3 to the power cube because here on the right hand side we have x to the power cube. And so we find some similarities there. There's the similarity at the level of their powers. Alright, that will lead us faster to the value of n. So we'll write 27 as 3 to the power cube. So we have 3 to the power cube raised to the power n is equal to x to the power cube. Alright, but the external power here is n, not 3. Remember, 3n can also be written as n times 3. You know multiplication is commutative. 3 multiplied to n is the same value as n multiplied to 3. Our aim is to have 3 outside so that we can have the overall power 3, just like here the power here is 3. So we will rewrite this as 3 to the power n raised to the power 3 is equal to x cubed. So we have this cubic expression equals to this cubic expression. All right? This index expression equals this index expression. Equality of two index expressions, p to the x equals b to the y. Equality is possible only when the powers are equal and the base are equal. Now we look here, the powers, you see, we look at the external power here. The power here is 3, the power there is 3. So there's already equality at the level of the powers. Now what about the base? The base here is 3 to the power n, the base here is x. So we have the right to say 3 to the power n is equal to x. Remember again, we want to solve for n. We're looking for n. We call all of this n. So we should solve for that n. The only operation that brings down the power in mathematics is taking logarithms. So we take logarithms of both sides, log 3 to the power n, and also log of x. Applying the law of powers, it will become n log 3 is equal to log x. We're looking for n, so we divide both sides by log 3. Alright, log 3 here cancels. It therefore means that n is equal to log x all over log 3. Remember again, n is our right hand side. Okay, we want to show that that right hand side is equal to log to the base 3 of x. Now we have log x. Remember, if no base is indicated, we know the base is 10. So we can proceed to apply the law of change of base. The law of change of base simply means if we put a new base here, then that same base will also be here. look at what we have on the left hand side. The base is 3. So it makes sense if we change the base. The base is 10. Remember, we don't need to write 10. We now change from base 10 to base 3. Okay? So if we do that, then we're going to have log of x base 3 all over log of 3 base 3. But what is log of 3 base 3? It simply means to what power do we raise this base to have the argument? To what power do we raise 3 to have 3 is 1. So this expression down here is simply 1. And so what we simply have is that n is equal to log x to the base 3, which is simply our left hand side. So finally, we have shown that the right hand side equals left hand side. We have shown that the right hand side equals the left hand side. All right, that does it for the first part of our tutorial question here. Remember, any questions or any comments, please indicate in the comment section. We will attend to the questions or the worries. Let's take the second part of the question. Second part, we are asked to find the real values of x for which 3 to the x is equal to, 3 to the x minus 7 is equal to 18 multiplied to 3 to the x. Find the real values of x. All right. Please, this is power negative x, power negative x. We have to be careful there. The power there is negative x. So let's go gradually. When we have any expression with the index power negative, we know it is 1 all over, it's written as such. A to the power negative n is equal to 1 all over a to the n. So let's start by arranging this one. This will now become 18 into 1 all over 3 to the power x. And we'll apply that law, which is just the same as 18 all over 3 to the power x. So we're saying 3 to the x minus 7 is equal to 18 all over 3 to the power x. All right? So now, if we multiply all through by 3 to the power x, our aim is to do away with this fraction. We multiply all through by 3 to the power x. We have 3 to the power x into 3 to the power x minus 7 is equal to 18 all over 3 to the power x multiplied by 3 to the power x. We'll multiply the left hand side by 3 to the power x, right hand side by 3 to the power x. So you see 3 to the power x here cancels. So we have here 3 to the power x multiplied by 3 to the power x minus, we're opening this parenthesis. We take this multiplied by this, take this multiplied by that. 3 to the power x multiplied to 7 now is equal to 18. We don't have any fractional expression anymore. All right, this multiplication, the bases are equal, so we have to add the powers. It becomes 3 to the x plus x. Here we just simply have 7 into 3 to the x is equal to 18. X plus x is 2x, so we have 3 to the 2x minus 7 into 3 to the x is equal to 18. Now we're gradually seeing a quadratic in terms of 3 to the power x, because if we rearrange this as 3x to the power 2 minus 7 into 3 to the power x is equal to, just bring the 18 inside, it becomes minus 18 is equal to 0. All right, we take this 18 from the right hand side to the left hand side. This is positive. When it's going inside here, it becomes negative 18. So that we'll have 0 on the right hand side. All right, remember 2x is the same as x times 2. Multiplication is commutative. So here we have 2x, now we have x times 2. There's no difference. It's still 2 multiplied to x, it's still x multiplied to 2. They have the same result. But we'll write it as such so as to see the quadratic that is hiding in terms of 3 to the power x. Now to bring it out very clear, let us bring in a new variable and call it 3 to the power x. So wherever we see 3 to the power x, we're going to write y. So this is going to be y squared minus 7y minus 18 is equal to 0. So we obtain this quadratic equation now. It's now very clear now. We collect our coefficients. Our a is 1, our b is negative 7, our c is negative 18. Okay? So if we put that in our quadratic formula, which is now in terms of y, we'll have negative b plus minus the root of b squared minus 4ac, all of that divided by 2a. So we're going to have negative 7 plus minus the root of negative 7 squared minus 4ac, all of that divided by 2a. Okay, let's write it again this way. We have y is equal to negative 7 plus minus root of negative 7 squared minus 4 into a into c, all of that divided by 2a. Okay, so all right, negative multiplied to negative becomes positive, plus minus the root of negative 7 squared is simply 49, and then this negative multiplied to that negative become positive. 4 multiplied to 1 is 4. 4 multiplied to 18. 4 multiplied to 18 is 72. Okay. All of that divided by 2. This gives us 7 plus minus the square root of, we'll add up all of this. We have 11 carry 1, 12. Okay. All over 2. Root 121. Square root of 121 is 11. So we have 7 plus minus 11 all over 2. So we either have y equals 7 plus 11 all over 2, which is 18 all over 2, which is 9, or we have y equals 7 minus 11 all over 2. 7 minus 11 is negative 4 all over 2. That gives us negative 2. Okay? All right, so we found values of y. But our question is in terms of x, so we're not stopping there. We have not solved for x already. We're supposed to solve for x and not y. But we remember the relationship between x and y. The relationship again is that y is equal to 3 to the power x. So let's take the first value for y. When y is 9, we're going to put 9 there. 9 is equal to 3 to the power x. All right, on the right hand side, we have 3 to the power x, an index expression. Can we change this one also to an index expression with a base 3? Yes, we know 9 is 3 squared. So we replace 9 with the number 3 squared. We get that. This index expression equals this index expression. Remember, equality is possible only when the bases are equal and the powers are equal. Now the bases are equal, it means automatically the powers are equal, since equality is already indicated. We are told that this is equal to this. That can only be true if only this power is equal to that power. So we see here the value of x is 2. All right, let's take the second case. When y equals negative 2. All right, when y equals negative 2, remember again that is the relationship between y and x. So we're saying 3 to the x is equal to negative 2. An index expression equal to a negative number, that is impossible. There is no possibility for such an equation, an equality to happen. There's no possibility for such an equality to happen. So here we have no solution to have 3 to the x equals to negative 2. So our only solution, the only value of x for which this left hand side equals the right hand side is the value x equals 2.